third solution for our algorithm that inserts a new element into the array A at index I works similar to the previous two solutions using iteration method. So what's the new idea of this solution? The idea of this solution is first to add the new element at the end of the array, specifically at index n. Then swap every two consecutive elements starting from index n-1 until reaching index I. Before we proceed, we would like to clarify why we are considering the end of the array is at index n. Remember that initially the last element is at index n-1, but after adding a new element into the array, the size of the array will be increased by 1. So therefore, the index for the last element will not be n-1, it will be the next to it, which will be index n. Now what do we mean by consecutive elements? We mean two elements that are next to each other. So when the algorithm starts with index n-1, basically we will swap the elements at index n-1 with n. So we will swap the numbers 6 with 10. When we go back one step, then we will swap these two elements. When we go back one step, we will swap these two elements until we reach the element at index I. Let me show you a demonstration on how the algorithm works on this example. In this example, we want to insert the value 10 at index 3. The first step of the algorithm is to add the new element at the end of the array. Now to swap the two consecutive elements starting from index n-1 until reaching index I, we will use a variable k that initially will point to n-1. The first swap will be between the element at k and k plus 1. And when the value of k goes back one step, then swap the consecutive elements at k and k plus 1. And again, when the value of k goes back one step, again we will do the swap between the two consecutive elements at k and k plus 1. And finally, when the value of k goes back one step, then swap the two consecutive elements between k and k plus 1. And now, since the value of k has reached I, then the algorithm should stop. So notice what happened to the new value that has been added at the end of the array. It has been shifted to the left until it has been placed at index 3. Now let us write the algorithm for this solution in a pseudocode. This is the third solution for the algorithm that inserts a new element in an array at index I. Similar to the previous two solutions, this solution is also an iterative solution. So we will give it a name like the previous two solutions. We say algorithm. The name is insert. The first parameter is the array. The second parameter is the index where we will insert the new element, and the last parameter will be the new element. As we discussed before, the first step was to add the new element at the end of the array. So where is the end of the array? Remember that when we insert a new element into the array, then the size of the array will be increased by 1. Therefore, when we pass the array as a parameter, we assume that the last index will be at n-1. But when we insert the new element, then the last element will be at index n. So we say a, n, takes the new value, which is e. Then, swap every consecutive elements starting from index -1, which is the end of the array, basically before we insert the new element, until reaching index I. So first we will swap these two consecutive elements, then we will swap these two consecutive elements until we reach index I. To process the array starting from index n-1 until I, we need a countdown for loop. So we write for, and the variable for the for loop is k, starts from n-1 down to I do. So in the first iteration, the first value will be pointing here, which is at n-1. We need to swap it with the next element. So these are the two consecutive elements. Basically, we add 1 to k. So we say swap the element at k with the one that is next to it, which is k plus 1. So how to call the algorithm from a main program? We say main, and we write the name of the algorithm as a method or as a function. We supply the array as the first parameter, and for our example, we want to insert the new element 10 at index 3. So the index will be 3 and the value will be 10. Now after inserting the new element, then the size of the array should be increased by 1. So we write n takes the value of n plus 1. And this completes the pseudocode for this solution.